Hello. So this is another talk I gave whilst I was working at Ultraleap. Originally gave it to a conference at Aberystwyth University, which is where I did my undergraduate degree. And what this talk is about is essentially how to teleport in VR with your hands. It was a bunch of different interaction research we did around 2022. We being me, Matt Filer, and Roy Clark. Um, and in this presentation, essentially, I'll go over the different prototypes we came up with and where we eventually settled on. Um, so yeah, let's get started. So first of all, I'll talk about what teleportation is, uh, why we care about it, and how we did some of the research. So what is teleportation? And this may be a bit of a silly question. I'm sure you all kind of already know, but to skip over the kind of definition of it, which is simply just to jump from one space to another, I guess, in a blink of an eye. Teleportation is a fundamental interaction in VR. It's something that is important because you need to be able to move around in these immersive spaces that you're in your headset. You need to be able to get from one place to another, and you can do this through smooth locomotion, but that can often lead to motion sickness and is often more complex. Whereas teleportation, because you just simply jump from one spot to another, doesn't cause motion sickness. And so it's a really powerful way of quickly moving without needing to worry about more complex ways to mitigate motion sickness in VR. For controllers, it's a pretty standard solved problem. So with controllers, you simply push forward on your thumbstick and then release, and wherever you're aiming at, then you teleport it. Pretty easy, right? So the same standards don't necessarily apply for hand tracking at the moment because hand tracking is so new compared to controllers. There's lots of different solutions that you'll see out there, and we explored a bunch of different ones, but none of them were really perfect, and none of them really felt like they were the solution. It's worth noting that locomotion systems in VR games are often part of the key selling point, the fact they've got a new different way to move around the space. But there's still standard ways that developers and designers can begin to build off of, and really wanted to find a way of teleporting with your hands that made sense. So why do we care? Ultraleap, why were we even bothering looking at teleportation? So procedural training is a huge part of VR and a big part of the business of VR. It's where people go through a training scenario in a headset, step by step, to learn the moves and what they need to do. It's often done by first time users, and people are often in and out of procedural training scenarios in about 20 minutes. So they have to be able to really quickly pick up interactions and learn them. Hand tracking is especially useful for procedural training because, unlike controllers, your hands don't need to be charged. And with controllers, there's a barrier to entry or friction as people see a controller and immediately begin to get overwhelmed with the amount of buttons and possibilities and different things they have to memorize. So how do we go about solving the problem of teleportation? One of the main ways we do this at Ultraleap was through design sprints. And these are a concept kind of originally put forward and invented by Google. If you search for Jake Knapp's name and design sprint or Google design sprint, you'll find a whole wealth of resources. And we really love design sprints at Ultraleap and have adapted them to work for us and to work for XR. So the idea of a design sprint is that you're skipping the building and launching part of a problem and essentially just looping through this ideation and learning stage so you can really quickly get to the core of a problem. They take about a week and they're fantastic. So you start on the first day and you map out the problem and you choose a target. On the second day, you try and sketch competing solutions and get to really cool ideas. On the third day, you decide on the best, and fourth, you prototype, and fifth, you kind of test with target customers. In VR, we have to change this a little bit because prototyping in VR is a little bit harder than in the 2D world. So we tend to squeeze Monday through Wednesday into one day and use Tuesday through Thursday as purely prototyping days. So for teleportation, we did 2 separate design sprints, and I'll get onto what those are next. Once we got to a good idea, we then refined it, built it into an application, and made some tooling out of it. We did lots of user testing throughout this to confirm that our suspicions and our hypotheses are true, and we tried to work out, based on user testing, what the best solution was. As I said at the start, there's only about 3 people working on this, so it wasn't a huge team, but it was enough to kind of arrive at a bunch of different solutions. Okay, so design sprint numero uno. We came up with a ton of different ideas in this design sprint. So you can see the wall is kind of covered with post-its there of different ways to locomote. And we tried to group them into distinct categories and come up with some good ideas out of this. And we each went away and kind of prototyped one teleport method each. This first one was done by Matt. Essentially, it's made up of the steps. So you grab both fists and wait for the timer. You aim with your index finger and you point to teleport. It kind of makes sense, but based on user testing feedback, people found that the discoverability of it was lacking. It was difficult to understand what you had to do unless you were already taught it. And the aiming technique was also difficult because it was a straight line out of your index finger, so you often had to point quite awkwardly down. As well as this, the whole waiting for a certain amount of time did cause some frustration for users. Next up, we had this idea from Rory, which was based on an idea from the game Budget Cuts. And it was really the idea to try and take that literal interpretation of teleportation and make some portals. So you pull the tab in your hand, you move your hand around to aim and see your intended position through the portal once you pull far enough, and then to activate it, you fully expand the tab as if you're enveloping yourself. The expansion aspect of this was pretty cool. Like it was fun to pull it over and go whoo, but the aiming part was quite difficult and difficult to understand how you were doing it. The portal also confused some people. They didn't really understand what was going on, and the change in terms of field of view and scale as you went through the portal caused some nausea, which is the exact opposite of what you wanted. Maybe with more refinement we could have got to a good idea here, but it felt like it was a little bit complex for our target use cases. Finally, in this design sprint is the method I tried, which was Rails. The idea here was, in procedural training, you may only want to go to certain points along your kind of world. And so if you constrained everything to a Bezier spline, maybe you could come up with an interesting teleportation technique. So to enable it, you pinch this ball on your hand. You pull it along a line to kind of choose how far along the Bezier curve you want to go. And then you release the ball to activate it. And this was an okay idea, but it had one major flaw, which was I didn't take into account the tracking FOV of the camera. So what would happen is users would look down at their hands, they'd pinch the ball, and then they'd look over there at where they wanted to teleport. And as they looked over there, their hands would go out of the field of view of the camera, which A, meant we couldn't track it, and B, meant because of a bug, they'd instantly teleport to wherever the ball currently was on the spline. So this just caused like absolute mayhem. People had no idea what was going on. It was already quite an abstract combination of things to understand, and added with that bug, it just absolutely failed. So those are the first 3 prototypes we came up with in the design sprint. And you're probably thinking, okay, that's interesting, Pip, but none of those are bangers. None of those are great. And you'd be right. And we agreed to, and we thought, you know what, we need to go back to the drawing board and take another go, because obviously none of these are the solution we want. And we tried to work out what went wrong in that design sprint. And one of the main things we thought was that we kind of spent way too long on one idea each, in that we used the 3 days to kind of really come up with almost a polished idea rather than just a quick hacky prototype. So you could see in the Rails video that things were kind of, you could do it with either hand. There was lots of lovely visuals and things. There was different ways you could do it. I'd fixed a lot of bugs around it. Basically, we'd spent too long refining something that we weren't even sure was worth the time doing so. So for Design Sprint 2, we changed tack, and instead we tried to do more of a scattershot approach. So we tried to come up with a bunch of different prototypes instead of just one each. Okay, so these were the first two prototypes I'm going to talk about for this design sprint, and neither of these made it into user testing because they just had some fundamental flaws with them. The first one was made by Matt, and this was upwards pinch, we called it. And so you'd turn your hand towards you, pinch and push up, and then you'd get a pinch ray to kind of aim with and locomote. The problem with this one, the reason it didn't make it to user testing, is you can see there, it conflicts with the Oculus system gesture. And this is the case across different headsets, not just Meta. And it meant that every time you tried to pinch up, you'd quite often activate the system overlay, and that'd be a big mess. You'd have to get out of it. It just wasn't worth it. It was a massive conflict. On the right here is Finger Gun. And we borrowed this interaction from a game called Finger Gun on the MetaQuest. So this one is pretty simple. You make a finger gun pose. You aim like this with a pinch position ray, and then to activate, you simply go pew, and you're teleported. We thought it'd be pretty fun, but unfortunately, the hand tracking model we were using at the time just didn't really track this pose very well, so we had to abandon it. The next two are did make it to user testing. So Squish to teleport was one I made. And essentially you make this pose in front of your face as if you're about to squish something in the distance. You use a ray that's from an estimated eye position, and then you pinch to activate. I thought this one was pretty cool, but the discovery of it was a little bit hard. And it was difficult to kind of understand what was happening, especially when compared with everything else, which used a ray. It felt very odd. It was a bit of a different convention, and as well as this, accidental activations were common. It was a little bit too easy to activate. Ignore the tracking going haywire there. I think there was a bit of a bug with the platform at the time. This one here was we called Come Here. So you'd have an open hand facing up, and I prototyped this one as well. You'd aim along the hand, and then to activate, you'd simply curl the hand like that. It was fine, and it kind of does afford a motion, which is nice. But the wrist twist motion was kind of super uncomfortable and kind of really tires out the wrist. Aiming with the palm upside down feels a little bit clunky. And in general, it wasn't really a take me there action that you were doing. It was more of a you come here action. So it didn't work too well as a concept. We tried out the really, really basic pinch to teleport. This was another one I prototyped. So we with this one tried a contextual enablement where it would just be enabled if you were looking at where a teleport point should be, or if you're looking at a desk here, it would be disabled. So you can see that as soon as I look up, it appears, and whenever I look down, it disappears. You aim with a pinch position ray, and as you pinch, you can drag to rotate where you're going to face when you end up at the teleport point. I really like that part. I thought that was cool. It's easy to use once discovered, but the fact it was always on did find some annoyance from users. Ray Latch Grab, this was another Matt Filer one. And the idea with this one would be it would always be on and only show when you began to aim towards a teleport point. So you'd aim with your palm, you'd grab and move upwards to activate it. There was some confusion on how to activate it once you kind of aimed, but once it was learned, people found it quite fun and easy to use. Almost as if you were like pulling a lever or going at this. It was pretty quick to get going with. This one was done by Rory and called Jewellery. And the idea here would be that you'd grab the jewel off of your finger, you'd get a pinch position ray, and that you'd release the jewel to teleport. Again, discovery on this one was a little bit tricky, but once it was discovered, people found it quite easy to use. The only problem was that people didn't really like touching their hands. The act of pinching your own hand is understandably a little bit uncomfortable and a bit weird to users. So that was the end of that one. As you can tell, it was a lot more positive an outcome than the first design sprint. There were definitely some things there that could be refined and taken forward. So we decided to do just that. We, based on our user testing results, we recommended using Jewellery, Pinch, and Latch Grab. And the one that was most promising was Jewellery, because it had this really nice enablement step where you just kind of grab it. So we thought we'd try to go forward and refine from here. So first thing I did was looking through contextual activation. Are we able to activate the teleportation method magically when a user needs it? So I looked at 3 different kind of intention signifiers here. The first was head data. Where's the user looking and where are they positioned? So if they're looking at the desk, obviously they don't want to teleport. Whereas if they're looking above the desk, they probably do. It kind of works, but it's again a little bit confusing and difficult to generalize. I looked at but I mean it was a good intention signifier overall, I guess. Hand data, I thought, well, maybe if a user stretches outwards outside of their kind of comfortable interaction zone, it'd be a good intent signifier. And that's what's happening in the GIF here. You can see this arc that appears at level with the hand. And as they stretch out, teleportation is activated. And as they stretch back, it's deactivated. This one wasn't a great idea. It was, again, a bit confusing and wasn't especially elegant. So we didn't go ahead with that. And finally, scene data. What's in the user's interaction space? What are they doing? So we thought here, and hopefully I'll do it with blocks. No? Okay, whatever. If you are interacting with a cube, like say you're grabbing something or you're kind of hovering over something, we wouldn't activate the teleport ray. In conclusion, you can see from those things that we were trying really small, subtle details, and it's a really hard problem to solve. The entire app really has to be built around the notion of contextual activation, rather than just having a more generalized solution that goes, okay, this is how you do it. And instead, you need to really think hard about when you're going to contextually activate locomotion. So after contextual activation, we looked at refining jump gems. And so we needed to really refine them because we were planning to use them in Aurora, which is a flagship VR application we were building for Ultraleap at the time. We needed to solve a number of different problems that we'd identified in user testing. The first was where to place it. It was uncomfortable on the hands. People didn't really want to touch their hands, so we needed to place it off of the hands. We needed to add some sound effects to it. In the user test, Rory had used a Coke can sound effect for each stage, so you'd have the sound of it, which was fun, but it didn't really match the interaction. We wanted to help with what it should look like, because the current jewelry didn't really afford the sense of motion and locomotion that we wanted. And we wanted to understand how you should teach it, because it wasn't necessarily the most natural to understand just from glancing at it. So the first thing I looked at was where it should be located. I tried it firstly on the arm, and this works really, really well. So I placed it further down the arm because we didn't want it to conflict with any hand menus that were on the hand, which worked really well, because you could look at your arm, grab it, and you were already kind of looking outwards into your scene with your hand in your right position to just get that flow going really well. The whole motion of this just felt fantastic because it was just one smooth movement as you went. The next thing I tried was maybe you can put it on your waist, I thought. And this one didn't work as well as the arm. The main problem here was that you'd look down at your waist to pick it up, and as you look back up, you were completely disoriented again. You had to reorient yourself in this virtual world, and so it really ruined the flow, unlike the arm position. So we decided to go with the arm. How it should sound. So we got rid of the sounds we had in the user test, which Rory had done as kind of a Coke can sound effect. So you'd get the sound as you did it, which was fun, but it didn't really suit the interaction. And instead, we kept it silent for a fairly long time, like a good few months. Eventually, we added sound back using some wonderful sound effects from Kenny. Definitely check out Kenny's free assets if you haven't already. They're fantastic. And immediately when we added sounds back, it became so much more understandable. The feedback you gain from adding sounds to any interaction is invaluable and one that's often overlooked. So I'm mainly including this kind of bullet point to remind people to not discount how good sound can make your interactions feel. So its design was quite difficult to discover and doesn't really afford movement. So instead we moved to this kind of conical pointer style design that is almost like an arrow on your wrist. I don't think we maybe nailed it. I think we could have done a little bit better with the design, but it was the best we could think of with the limited time we got to do it with. The main problem with this current iteration is that it's a difficult one to describe when you're outside of the headset. So yeah, but it's not too much of an issue because we worked really hard on how to teach it. So we took Jump Gems to CES when Aurora was in its beta. It's beta release, and the only thing we had was the little kind of, hang on, I'll wait for this video to restart. Come on. Yeah, these little simple hints. So there's a pinch me and then unpinch me. And these we hoped would be good enough to teach it, but they weren't, because the interaction was so new that people didn't really even understand what to do there, and they were overwhelmed by the rest of the experience. So instead we had, I'm going to rewind this bit a little, we had 3 different kind of tutorial prompts to try and help people understand it, and this really made it flawless. So we had we kept the simple hints because they were great for people who had already experienced Jump Gems. We added in some ghost hands that kind of repeated on a loop, showing people how to teleport, and came on after a number of seconds after people hadn't teleported and we expected that they should have. And then finally, at the start of Aurora, this robot over here teaches you how to do it and does it himself and jumps over to the next island waiting for you to follow him. So how can you define your own locomotion method? We analysed all the different locomotion methods we'd seen when we were researching them, as well as building them, and we came up with 3 key teleportation steps. So first is enable, then aim, and then activate. So enablement, how do you build a good enablement step? So it's got to be quick to access and hard to accidentally activate. So you want people to be able to access it at any time because they want to be able to teleport quickly, but you want people to not accidentally jump all over the place. Like the learning we had from the wrist position, you want to be able to activate whilst looking at your intended destination point to try and keep your user in the flow. You don't want people to have to look away from where they want to teleport before teleporting because that really ruins their flow. Okay, so aiming is a fun one and it's quite detailed in terms of the different decisions you have to make here. So you have 2 main ones. The first is the far field technique you'll be using when you're aiming with it. And the second is how much control you give to the user. So in terms of the far field technique, it really depends on the context of the interaction, and you really want that technique to map it, to map to it. So a pinch ray mapped to a pinch activation really makes sense, because you pinch to activate, and now it makes sense that the locomotion technique is coming out of your pinch position. Or maybe a palm ray maps to a grab interaction, because it's more of a whole hand interaction you're doing there. And matching the ray to the activation method really helps users understand and remember what is going on. You want to decide how to use your direction, for example, a straight versus a parabolic line. And what I mean by that is, sure, you'll have a direction. So this direction here is, to simplify it, is through the shoulder, through the pinch position, so you get a nice stable pinch line. It's a little bit more complex than that, but I won't go into it. But anyway, that's just a direction that's straight, right? So it's a straight line. You may want to curve that off if you're doing with a parabolic line, to allow the users to aim at the floor more easily. But maybe you need to do it straight because you're aiming at stuff more at their chest level. In terms of the control, you want to decide kind of more of a free aim versus anchors, so users could aim anywhere they want to, or they could just aim at teleportation anchors, and it depends on the experience you're building on what's the correct solution there. You also want to decide on how much control you give your user in terms of what anchor they're aiming at. So you can use different raycasting techniques to do this. So if you just use a raycast, which is a single line going through space, like a pixel wide, they can only really aim at one thing at a time, and that's quite precise, fully user given intent. Whereas if you use a sphere cast or a cone cast, where it's a 3D bounding space traveling through your virtual world. So a sphere cast is lots of different kind of a cylindrical ray going through the world, and the cone cast is a conical ray. There can be the potential that you're aiming at multiple things at once, and then as an interaction designer, you need to understand what the best teleportation anchor is the best one to aim at from the user's point. I understand I haven't really explained that too clearly there, but there's lots of more resources around this on Ultraleap's XR guidelines, so I'd encourage you to read that. Finally, activation. You need it to be hard to accidentally activate, comfortable to use, memorable and robust to aim. So you don't want to accidentally activate it before a user is done aiming. It needs to be comfortable, because users may be in this stage for a while as they decide where they want to teleport to. It needs to be memorable, so users are actually able to get there. And it needs to be robust to aim, in terms of you don't want your activation action to accidentally change where you're aiming as you do it. So that's it. Thank you very much. I know that's a fairly quick one, I hope. If you've got any questions about locomotion or teleportation with your hands, feel free to reach out or comment below. We have some design guidelines up on Ultraleap's docs website here that go over kind of locomotion. Definitely check them out if you want to understand more. But thanks.